Imagine if AI could truly think like humans. What if it could understand and make decisions just like us? That's the challenge we're tackling today. It's a fascinating notion shaping the future of technology. But here's the catch. Current AI often falls short in truly understanding things like humans do. Why does this matter? Well, imagine unlocking a new level of AI potential, making it smarter and more adaptable. In this video, we delve into why AI thinking like humans is crucial and explore innovative ways to make it happen. Stick around to discover the exciting future of AI and human-like cognition. The big challenge. Now let's talk about the challenge of making AI think more like humans. Firstly, the current AI models have some limitations. They struggle with really understanding things and putting different pieces of information together, what we call compositional reasoning. It's like they're missing the aha moment when everything clicks. This lack of true understanding often leads to issues in how AI behaves. For example, AI models can sometimes be all over the place, saying things that don't really make sense or contradicting themselves. Imagine asking a question, and the AI gives a great answer initially, but as you continue, it starts to lose track or even gives conflicting responses. That's the coherence and consistency problem we're dealing with. Innovative training parts. But here's the interesting part. A new study suggests that the key to making AI smarter might be in how we train it. This study dives into the methods we use to teach AI, and it's pointing out that we might be able to make AI more human-like in its reasoning. Let's explore how tweaking the training process could be the missing link in getting AI to think more like us. The Transformer Model Foundation. The first key aspect is the use of a standard transformer model. Think of this model as the foundation. It's the same type of structure we find in popular AI systems like ChatGPT or Google's Bard. Instead of starting from scratch, the researchers chose to work with what's already there, but with a twist in how they train it. Introducing a new language. The real game changer here is the set of tasks designed to teach the model a made-up language with symbolic elements. It's like creating a whole new way for AI to understand and interpret information. The language they used had words that didn't mean anything in the real world, like Dax or Kiki. Each of these words had a specific role, either representing a color or performing a function, creating a kind of AI-friendly jargon. But here's the catch. The AI wasn't given any info about what these words meant or how they worked together. It was like throwing a bunch of made-up words and their corresponding colorful dots at the AI, expecting it to figure out the patterns and relationships on its own. The training process. This approach is quite exciting because, unlike traditional training methods that involve loads of data, it's more like giving the AI a puzzle to solve. Let's see how this unique training setup helps the model develop a deeper understanding and better reasoning abilities. Firstly, the model demonstrated a remarkable ability to recombine components and understand novel expressions. It's like teaching someone a new language and then seeing them create sentences that they've never heard before. The AI could take these made-up words and put them together in ways it hadn't been explicitly taught, showcasing a level of flexibility and creativity. To put it to the test, the researchers asked the trained AI to respond to new phrases and checked if it followed the implied rules of the made-up language. Surprisingly, it did, even when faced with configurations of words it hadn't seen during training. This suggests that the model wasn't just memorizing specific examples, but genuinely grasping the rules of the language and applying them in new situations. In a head-to-head comparison with human participants, the optimized neural network, born out of this new training protocol, achieved impressive accuracy. At its best, the AI responded 100% accurately, outperforming human answers that were correct about 81% of the time. In contrast, when the same test was given to GPT-4, a large language model, it scored only 58% accuracy. This hints at the potential of the new training method in creating AI models that not only understand but also outperform humans in certain tasks. Impressive results. These results are quite promising, as they show that this unique training protocol can lead to AI models that don't just regurgitate information, but truly understand and reason like humans, marking a significant step forward in the world of artificial intelligence. Let's hear what the experts have to say about this breakthrough in AI training. Thought cloning. Now let's shift our focus to another fascinating aspect of AI development: the introduction of thought cloning as a technique. In the realm of AI, behavior cloning has been a common approach. It involves training models by exposing them to data generated by humans, enabling them to mimic observed behaviors. However, this method has its limitations, primarily the lack of understanding behind the actions taken. Thought cloning emerges as an innovative alternative. Unlike behavior cloning, thought cloning trains AI models on both actions and the thoughts or reasoning processes behind those actions. It's a step beyond mere imitation, aiming to impart a deeper comprehension of why certain actions lead to specific outcomes. The underlying hypothesis of thought cloning is straightforward. If an AI model is trained on both actions and the corresponding thoughts, it can establish the right associations between behavior and goals. By simultaneously providing the model with streams of information related to actions and thoughts during training, the hypothesis suggests that the model can learn faster and perform better. The benefits extend to improved generalization to new situations and enhanced safety by expressing the reasoning behind each action. Essentially, thought cloning aims to bridge the gap between AI actions and the underlying cognitive processes, bringing a level of understanding and transparency that behavior cloning lacks. Dual-component architecture. Thought cloning employs a sophisticated dual-component system within its architecture. The upper component processes streams of thoughts and environment observations, attempting to predict the next thought that aligns with the model's goals. On the other hand, the lower component receives environment observations and the output from the upper component, focusing on predicting the correct action to achieve the intended goal. This layered approach mimics a cognitive process where higher-level thinking influences lower-level actions. The collaboration between these components forms the basis of thought cloning's unique architecture, providing a framework for the model to reason and act cohesively. The methodology involves providing the model with two essential streams of information during training: the actions taken and the corresponding thoughts or explanations behind those actions. This dual input system allows the model to learn the associations between behavior and goals. As the model progresses through training, it uses the sequence of thoughts and actions produced by humans as a form of ground truth. By minimizing the loss in thought and action predictions, the model refines its parameters, ultimately gaining the ability to generate the right sequences of thoughts and actions for unseen tasks. This holistic training methodology is pivotal in instilling a deeper understanding of the reasoning processes behind AI actions. Baby AI platform. To put thought cloning into practice, researchers utilize the Baby AI platform, a grid-world environment where an AI agent must complete diverse missions. The advantage of this platform lies in its ability to programmatically generate worlds, missions, solutions, and narrations for training AI systems. In the application of thought cloning, a dataset comprising 1 million scenarios was created. This dataset served as the foundation for training the thought cloning model on a variety of tasks, providing the necessary diversity to enhance the model's generalization capabilities. The careful curation of this dataset played a crucial role in demonstrating the effectiveness of thought cloning in diverse and complex scenarios. To highlight the superiority of thought cloning, the researchers conducted a comparative analysis with behavior cloning. 2 different models were trained, one using pure behavior cloning, receiving only environment observations, and the other utilizing thought cloning, receiving both behavior data and a stream of plain text explanations for the reasoning behind each move. The results of this comparative analysis showcased the enhanced performance of thought cloning. Not only did it outperform behavior cloning, but it also exhibited faster convergence, requiring fewer training examples to generalize to new and unseen tasks. This comparison underscored the tangible benefits of thought cloning in improving AI capabilities over traditional behavior cloning methods. Now, let's dive into the central question. Can you train an AI to think exactly like you? Yes, this leads us into the world of thought cloning, considering how it could help AI understand human thinking. As we journey through this, it's not just about the technical side, but also about ethics, making sure AI shares our values. Looking ahead, AI development seems promising with thought cloning, offering a chance for deeper teamwork between humans and AI. What are your thoughts on this mix of human thinking and AI abilities? If you have made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.